And that means we are actively exploring every potential local geometry on that object. Then we start to ask one question, which is if now we have two dimensions to scale our dataset. One dimension is the number of training objects. Another dimension is like how dense we sample local geometries on each training object. So after we run such analysis, we found that when we increase the number of training objects, diversity of local geometries that we can have actually does not increase a lot. But when we increase the number of sampled local geometries on each training object, like diversity of local geometries increase dramatically. So that actually motivates us to just have a training set with limited amount of training objects, like 40, but we really densely sample on those training objects. And such motivation, observation allows us to like curate a small data set in terms of number of training objects, but it can really generalize well to hundreds of unseen test objects.
Yeah, this is actually a really nice, really interesting result. I think it's
Yeah.
a big advantage of presumably of your model operating in 3D, right? As well,
Yeah.
because it'd be very hard to get this kind of result if you were just doing end-to-end learning from cameras, right?
Yeah,
Like,
exactly.
yeah. Nice.